The machine only understands binary numbers, like 0 and 1. So if you input a number like 23, a string like hello world, or a large data, your input will be converted to a series of binary numbers so the computer will understand. In this video, let's discover how to convert a decimal number to binary. Let's convert 23 to binary. You need to be familiar with the powers of 2. 2 to the 0 power is 1, 2 to the 1 power is 2, 2 2 is 4, 2 3 is 8, 2 4 is 16, 2 5 is 32, 2 6 is 64, and 2 7 is 128. Now this range of numbers exceeds my number 23. That's why I'll only be using these numbers, the numbers that don't exceed 23. So the highest base 2 number less than 23 is actually 16. So I'm gonna write over here 16, and I'm gonna add 1 right down of 16. Now I'm gonna ask myself, 16 plus 8 is equal to 24, and that's not 23. So we can't use 8. What I'm gonna do, I'm gonna add a 0. Now, can we use 4? So 16 plus 4 is actually 20. So yes, we can use 4. I'll write here plus 4 and add 1 over here. Can we use 2 and 1? Of course, because 2 plus 1 is 3. We have 20 over here, so we got 23. That's why I'll add 1 and another 1. Now this is the binary format of 23, written in 5 bits. Now I can do it in 8 bits by adding 3 zeros over here. I'll delete the line, and this is the binary format of 23 written in 8 bits. So by using the powers of 2, I've been able to write 23 in binary format. Let's go for a bigger number. I'll say 91. So I'll delete everything, but I'll leave for you those. I'm gonna write over here 91. Now because 91 is a big number, we'll be extending the range till here. 128 exceeds 91, so we won't use it. So the highest base 2 number less than 91 is actually 64. Now we could use 64, so I'll put 64 over here and add 1 down here. Now if I say 64 plus 32, I'll get 96, and 96 exceeds 91. That means I cannot use 32. I'll add a 0. Can we use 16? So 64 plus 16 is actually 80. So yes, we can use 16. I'll add 16 over here and add 1 over here. 64 plus 16 is 80. 91 minus 80 is 11, so we need more 11. Can we use 8? So we have right now 80. If I add 8, I'll get 88. So yes, we can, and we still have 3 more. Can we use 4? No, because it will exceed 91. So I'll add a 0. Can we use 2? Yes. And now can I use 1? Definitely. And I'll get 91 in binary format. So I'll add here plus 2 plus 1. So 64 plus 16 is equal to 80. 80 plus 8 is equal to 88. Those are equal to 3. 88 plus 3 is equal to 91. So we got 91, our decimal number, to binary format. This is in 7 bits, so I'll add a 1 bit over here. That will be in 8 bits. You can add 16, 32 bits, but I'll stay with 8 bits. Right now, let's go for a number like 180. So 180 is a big number. That's why I'm gonna delete this range. And this time I'll be using 128, this range. After 128, we have 256, but 256 exceeds 180. So the highest base 2 number less than 180 is 128. So I'll add 128 over here. And I'll put 1. Can we use 64? So actually 128 plus 64 is equal to 192, which exceeds 180. That's why we cannot use 64. I'll add 0. Can we use 32? So 128 plus 32 is equal to 160. So yes, we could use 32. So I'll add a 1 over here because we can use 32. Now 128 plus 32 is 160. So 180 minus 160 is 20. So we need 20 more. Could we use 16? Yes, we can. So I'll add 1 over here and I'll add plus 16. Now we need 4 more. Can we use 8? Definitely not. So I'll add a 0. Can we use 4? Yes, we can. I'll say plus 4 and we got 108. So I'll add a 1 over here and the rest will be 0. So this is the binary format of the decimal number 180, written in 8 bits. Now let's use the same example to demonstrate the second method. So I'll use 23 first, and the second method consists of dividing by 2 until the quotient is equal to 0. So what I'm gonna do now is I'm gonna divide 23 by 2. So if you divide 23 by 2, you'll get 11.5. So I can say that I got 11 remainder 1, right? So if I also divide 11 by 2, I'll get 5 and a remainder of 1. So again, I'll divide 5 also. 5 divided by 2, I'll get 2, remainder 1. But if you divide 2 by 2, you'll get 1, remainder 0. But 1 divided by 2 is equal to 0, remainder 1. And that is the binary format. But how to read it? Well, you read from down to up. So we got 1 0 1 1 1. And this is the binary format of 23 where we discovered it in the beginning of this video. I'll delete everything, and this time let's go and do it for 91. So I'll write over here 91. 91 divided by 2 is equal to 45.5. So we got 45 remainder 1. Now let's divide 45 by 2. We will get 22.5, that means 22, remainder 1. I'll divide 22 and I'll get 11, remainder 0. Now I'll just zoom out a bit. 11 divided by 2 is 5.5. So 5, remainder 1. 5 divided by 2 is 2.5. So 2, remainder 1. 2 divided by 2 is 1, remainder 0. And 1 divided by 2 is 0, remainder 1. Now to read this binary format, we start from the bottom all the way to above. And we got 1 0 1 1 0 1 1. And that is the same binary format that we got in the other method. So I want to know down in the comments which method you think is more easier. Right now, let's do the same method for 180. So if we divide 180 by 2, we'll get 90, remainder 0. Then 90 divided by 2 is 45, remainder 0. 45 divided by 2 is 22.5, that means 22 and remainder 1. 22 divided by 2 is equal to 11, remainder 0. I'll zoom out, and 11 divided by 2 is equal to 5.5, that means 5, remainder 1. And 5 divided by 2 is 2.5, that means 2, remainder 1. 2 divided by 2 is equal to 1, remainder 0. And 1 divided by 2 is 0, remainder 1. And to read this binary format, we start from the bottom all the way to above. And so we got 1 0 1 1 0 1 0 0. That is the same binary format that we got with the previous method. Alright, this is how you can convert decimal number to binary. Make sure to tell me down in the comments which method did you like the most. Also, make sure to hit that thumbs up and subscribe to that channel. And how about checking out what really is the metaverse that Mark Zuckerberg is buzzing about, which $10 billion was invested in it. So, see you there.